all right.
Yeah, lesson 8.3. Finding angles using cosine law. So you have a little acute triangle there. It's got three sides labeled SSS and angles labeled AAA. We're going to talk about that triangle in a little bit. But if you know three of those measurements, any three, you can solve the whole triangle.
Yep.
Okay, you can solve the whole triangle using sine law and cosine law. Now, which law you use depends on the information that you have been given. Before we get into explaining that, go ahead and try and write the sine law and the cosine law from memory. And you can double check up here to see how you did. I wrote my sine law both ways. Is it important where I use capital letters, where I use lowercase letters?
Yes.
Why?
Because if you don't, then it all basically vertices, I think they're called.
Thank you.
Oh.
Yep. Points and angles use capital letters. Okay. Lines or side lengths are lowercase letters. Always. Good. Try cosine law if you haven't already.
Let's start. Oh yeah. Wait, what is it?
All right, I just wrote one version of it. Let's say you were looking for a side length. Doesn't matter what side length it is. Any of the three makes no difference. Okay, that side length is going to go over here by itself. And then you've got the other two known side lengths, right there and right there. And then you have the opposite angle of the side length that you're looking for right there. And this angle, while it's opposite of side length A, is contained by side length B and side length C. So that's like you have a triangle and you know this, and the contained angle, and you're looking for the opposite side. Okay? Once you have the opposite side, you could use sine law in order to find this guy, sum of interior angles in order to find that guy, and then you're done. Good, good. Now, there is another way to write this cosine law. We're going to get to that just in a second after we draw some diagrams here. So I'm just reading from your notebook on 8.3. Underneath that triangle, underneath sine law, cosine law, it says, consider the acute triangle above with each side labeled S and each angle labeled A. When determining the best strategy for solving an acute triangle, we consider the information that we know. Often we use short forms like SAS to identify which pieces of information we know. The short form SAS means that we've been given two adjacent sides and their contained angle. The short form SSA means we have two adjacent sides and the angle, an angle that is not contained. What strategy would you use to solve a triangle when given the following information? So let's think about our triangle. Let's say you're given SSA. Let me explain how this works again. SSA in a general diagram basically just means you're going around the triangle. You have an S. You go around the triangle. The next thing that you have is another S. And the next thing that you have is an A. Does that make sense?
Yeah.
So let's say you have side, side, angle. What strategy can you use to solve? Sine law or cosine law?
We can use cosine law.
No, you cannot.
You can use sine.
You can use sine law because you have opposite information. That means you have one complete ratio, which means sine law is going to be the easiest one to use.
Oh yeah. Sine law. So what do we write in the boxes?
What strategy would you use?
Yeah, but like.
All right, side, angle, side. So I've got my triangle here, and I'm just thinking I'm going around the triangle. Doesn't matter where I start, but I've got side, and then working around I have angle, and then I have side again. So now I have two sides and their contained angle. Do I have opposite information anywhere?
Nope.
Nope, I don't have any side and its opposite angle or angle and its opposite side. So what do I have to use?
Cosine.
I have to use cosine law. Okay, I'm going to use cosine law to solve for this side. Okay, if I'm solving for this side, then I have all the other information, right? I have both other sides, and I have its opposite, the side's opposite angle. Okay, all right, let's think about an ASA triangle. Think about an ASA.
Would there be an A?
ASA. How am I going to solve that triangle? I can't use cosine because I don't have, I need either all three sides or I need two of the sides and a contained angle. This time I have two angles and a contained
You
side.
have two angles, which means you can use those two angles to figure out the last angle, because the sum of interior angles is 180, which gives you opposite information so that you can use sine law.
And that, thank you, very, very good. Okay, that's going to be sum of interior angles, then sine law. Okay, over here you could do cosine law, then sine law, but the key is just remembering the first thing that you're going to be able to do. And actually, you're not going to have these necessarily memorized, but you'll be able to look at every triangle and say, can I do this? Can I do that? Can I use sine law? Yes, go ahead. No, cosine law. All right, last one to think about here for a second. We've got side, side, side. So side, side, side. I don't have any angles. Do I have any tools that allow me to solve this?
Yes.
What is it?
I have no idea.
Okay, so I can use a cosine law, but look, this time I know this, 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 I don't know this. So again, I can use cosine law, but the unknown is kind of lumped over here with all of the known, with a bunch of known things, and it's going to take a lot of rearranging. So there is actually another way to write the cosine law in which we rearrange all of this before subbing in our numbers. Okay, so that's what I'm going to show you right now at the bottom of your page, and then we're going to head into a couple of examples, and it shouldn't take us too long today.
So what's the answer?
Yeah, so the answer here is cosine law, and I'm going to call it rearranged. Rearranged. For today, we'll call it cosine law rearranged in order to solve for an angle. But once you start using it more often, it's just the cosine law. It's the exact same. It's just been rearranged. But who says this one hasn't been rearranged and the other one hasn't been rearranged, right? You know what I'm saying? It's kind of arbitrary. It's just the cosine law.
It's probably the most next.
Okay, just quickly, I'm going to show how you get from one version to the other version. So I'm going to start with the one that we already know, which is a squared equals b squared plus c squared minus 2bc times the cosine of a. And all I'm going to do here is use my order of operations in reverse in order to solve for the cosine of a. This is essentially what I'm doing. So the first thing, I see that this cosine of a is in this big group of multiplication. Okay, so I'm going to leave that alone, and for now I'm just going to subtract square root of b squared and c squared from both sides. Okay, so over here on the left, that's going to give me a squared minus b squared minus c squared.
Right.
Subtract both of these guys from both sides, and over here it's going to leave me with negative 2bc times the cosine of a. Okay, now don't be tricked. The cosine of a is just one thing. It's a ratio. It's just going to end up being a number. Okay, probably with a bunch of decimals depending on the triangle. But it's being multiplied by c and by b and by 2 and by negative 1. Okay, so what I'm going to do over here is I'm going to divide both sides by, and I'll show this step, I'm going to divide both sides by negative 2bc. Over here, I'm going to divide by negative 2bc.
I'm getting a lot of negative.
No, don't do that yet. Okay. On the right-hand side, it's just going to leave us with the cosine of a, which I can't separate any further. Okay? I could take the inverse cosine of both sides at this point, but I'm not gonna. We're going to leave it in terms of the cosine of a. That'll help us remember that it's the cosine law. Over here, I'm going to do a couple of steps at once, okay? Well, I'll do one and then I'll rearrange it after. But look what happens here. Because I'm dividing by a negative, I'm going to actually allow this negative to change the sign of everything in my numerator, okay? So it's going to look like this. I'm going to not have this anymore because I'm dividing it out. And instead, I'm going to have negative a squared plus b squared plus c squared in the numerator. In the denominator, I just have 2bc. Okay, so all I did was factor out that negative from top and bottom, really. Now, this sentence is pretty awkward. It starts with a negative, but you can kind of see it's nice ABC. But
Yeah.
here's what I'm going to do. I'm going to write it so that my cosine is on the left. So I've got the cosine of A. And on the right-hand side, instead of starting with my negative term, I'm just going to put my two positive terms first. B squared plus C squared minus A squared. Okay, I can do that because all I really have in the numerator is I have a negative term, negative A squared, positive B squared, positive C squared. I still have that. Positive B squared, positive C squared, negative A squared, and the bottom is over 2BC. Now, this is the cosine law rearranged in order to solve for an angle. It too looks really complicated, but it's actually quite simple to remember. If I'm looking for the angle A, remember we're in a situation here where we have side, 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 and we're just going to be looking for one of the angles. Because once I have one of the angles, I have opposite information, can use sine law. Then I'll have two angles, I'll use interior sum of angles. Sum of interior angles is 180 to finish it off. But okay, so if I'm looking for angle A, then here's what I have to remember. Its opposite side length, lowercase a, is the side length that's going to end up being the negative square. Does that make sense?
Yeah.
So always this capital A is partnered with this lowercase a. If you're looking for capital A, angle A, then the side length that's negative is going to be its partner. Okay? And then the other two just get plugged in. B squared and C squared, and then B and C. Just like you did last time, except this time two of them are underneath a division symbol. Okay? But you still have 2BC. So you know all three sides in this situation. You're basically just plunking in this value, this value, this value, this value, this value, and then carefully solving it. Okay, we're going to do a handful of them. So heading into example 1, you'll notice that these are already, example 1 and example 2 go right ahead to word problems. So in your practice problems, you'll have a couple that are just triangles to solve, but here we're going to interpret some word problems at the same time. So we have 3 towns are connected by 2 roads. You have it drawn. You've got Brookside down to Rolling Meadow is 10 kilometers. Then you've got Rolling Meadow across to High Cliff is 15 kilometers. And you don't know BH. Okay, that's what we're going to be trying to solve, it looks like. The third road is planned. It will directly connect Brookside with High Cliff, which are 16.5 kilometers apart. Okay, so it actually gives you that as well. That road doesn't exist yet, but they know that these guys are 16.5 kilometers apart to the nearest tenth of a degree. And we need to find the angle to the nearest tenth of a degree between the new road and the existing road from A, Rolling Meadows to Brookside. So that's this angle. Okay, this is going to be question A, finding angle B. And the new road, the angle that it makes with the old road from Rolling Meadows to High Cliff, that's going to be problem part B that we're solving. Okay, In part B, we're going to solve for angle H. Question. Do you think I'm going to have to use cosine law for both of those?
Yes. Wrong. We won't, because we'll have one angle, which means we can use sine law,
Good.
not cosine.
You would have already found it. So I'm looking at here. I've got a simplified diagram with my side lengths. I don't need that dotted line that they give you. I can fill that in because I don't care that it's not existent yet. I just want something to look at. And the new road will make unknown angles B and H. Okay, we already know angle R, or at least they could know it if they wanted to, but they don't really care. They just want to know how to start this new road from here and start it from there and get a straight line going across. So we're going to use cosine law first to find angle B. And in the example, it uses cosine law both ways. It uses it the original. That's why your page is split into two parts there. We're just going to use the right-hand side. So just use the right-hand side, and I'm going to write my cosine law for an angle. Okay, again, they do it in the book for a side length, and then they rearrange before just using the new formula. I'm just going to go ahead and use the new formula. So we're looking for angle B. So on the left-hand side, I've got the cosine of angle B. Now I know that I've got a division line. And the other thing that I know for sure is that over here, the last thing in the numerator is going to be negative b squared. Okay, and now I can fill in the other parts. I know that the numerator is going to be my other two side lengths squared. So I've got r squared plus h squared. And in the denominator, I have 2rh. It's just 2 times the two side lengths that I know already, that aren't b. And from here, I can start filling in my information that I know. So the cosine of angle B are, and again, this doesn't even matter what order I put them in, as long as I make sure that B is the one that's getting subtracted, okay? So that's going to be 15. So I just have to make sure that 15 goes here and the other two go here. And again, I don't care what order I put them in because addition is commutative, but for the sake of the example, I'll try to put them in the right spot. So in the numerator, I've got 16.5 squared plus h squared. So that's plus 10 squared, and then minus 15 squared. In the denominator, I have 2 times. And now, by the way, if you did the top right, do you even need to look back at your diagram to get the bottom?
Nope.
No. I can just take this first number, 16.5, and my second number, 10. Done. Now, there's a couple different ways you can do this. I could take the inverse cosine of both sides and put this whole thing inside a big ugly bracket, inverse cosine of this whole thing. Okay, I don't do it that way. I try to make it smaller first. There's a couple different ways you can make it smaller. You could just do the numerator and then just do the denominator and then divide them and then take the cosine, inverse cosine of both sides. That's not a bad way to do it because with only one decimal place here, I'm not going to get a long string of unknown decimal places, the kind of answer that I would want my calculator to store for me. I'm not going to get that. So I could just do it that way and then write my whole answer and then copy it back into my calculator. It's not a big deal. I wouldn't lose information because it's not rounded. So let's do it that way. I'll do it step by step. We'll just do the numerator. 16.5 squared plus 10 squared minus 15 squared. Okay, end up with 147.25. 147.25. Okay, I'd probably think about that answer and see if it's true. Yeah, this is about 100. Yeah, this is about 300, maybe 250. This is 225, so that's pretty much the sweet spot right there. And then the denominator, I can do the same way. I've got 2 times 16.5 times 10. That's 330. And now I can take the inverse cosine of both sides. That's going to leave me with just angle B here. And over here, I'm going to have the inverse cosine of And because I want to go faster in my practice problems, I'm just going to write answer there. What does that mean? What is
It means that the answer from the previous question
Yeah.
is now inserted into
It means I'm going to do this in my calculator first, and then I'm going to hit enter, and then I'm going to hit second function cosine, second function answer. Okay? And that's going to give me the angle B, and I'll decide if I'm using an approximate answer. I'm sure I will be. But we've got 147.25 divided by 330, enter. Second function, cosine, second function, answer, enter. 63.5, approximately 63.5 degrees. All right, that was angle B. That's right here, 63.5. All we did was use cosine law, set it up properly using the letters that are in your diagram. Do not try right off the start to use the cosine of A equals B squared plus C squared minus A squared over 2BC and then sub in your values. First, change the general equation to identify your letters. Then it's much easier to plug it in. In step B, we're asked to solve for angle H. What strategy am I going to use?
We're going to use sine law.
We're going to use sine law, okay? I have opposite information here. I've got angle B and side B, and I have side length H. I'm looking for angle H. So when I write sine law, what part of the ratio is going to go in the top, in the numerator?
The sine.
Yeah, the sine of H is going to start me off right here because that's what I'm looking for. Over here I know, and I'll write every step. Sine of B. Down here is going to be the length H, and here's the length B, and now I can simply sub in what I know. I know that the length H is 10. I know that the sine of B, I know B is 63.5, so I'm going to go sine of 63.5, and the length B is 15. How do I solve for the sine of H?
We first multiply both sides by 10.
Multiply both sides by 10. On the left, that's going to leave me with just the sine of H. On the right, in the numerator, I have 10 times the sine of 63.5 over 15. And I can do this a couple different ways. I can plug this into my calculator, store the answer, then hit inverse sine, second function, answer. That's probably what I would do. Or I could do inverse sine and then put this whole thing in brackets, but then I need to make sure I'm good with my brackets. I know how to do it properly in my calculator, or I'm going to mess it up. But I just do this, and I actually do this in 2 steps. I go 10 sine 63.5, enter, divided by 15, enter, and then I'll take second function, sine, second function, answer, enter. 36.6. 36.6 degrees, and that is approximate. So we got the measure of angle B, 63.5 degrees. We've got the measure of angle H, 36.6 degrees, and we would wrap those up into a final statement that says, you know, the angle between the new road and this road is this, and the angle between the new road and this road is this. Yeah? We're not going to do that. We're going to carry on. Any questions there? Example 2, solve an acute triangle. Oh boy. What's the problem with example 2? They don't give us a diagram. So I'm going to read it. You try to draw your diagram.
Horizontal line.
Runners in a 10-kilometer race follow a triangular course. The 3 legs of the race in order are 3.8 kilometers, 2.4 kilometers, and 3.8 kilometers. Find the angles between the legs in each pair to the nearest degree.
Hey,
Go ahead and try and draw that triangle.
this is an equilateral triangle.
Yeah, if you've figured out that it's isosceles, go ahead and draw an isosceles triangle. If you haven't, then it really doesn't matter what it looks like because you have the side lengths. So I'm not even going to really pay too much attention to that, but I know I've got my first leg is 3.8. I'm making an acute triangle, and I know I'm going to end up with 2.4 and another 3.8. And if it doesn't look acute, who cares? Okay?
That's a cute chapter.
Now, I'm asked to find each of my angles, so let's give this thing some letters. Let's call this triangle ABC. And now all I need to do is solve. And again, we're going to be using that rearranged cosine. And I'm going to be using it for, what do you want to solve for? Angle A?
Yeah, let's do that.
Okay, so let's call cosine of A equals, see if you can write the rest of this from memory. I'll give you a hint. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. My other two sides go here. B squared plus C squared minus A squared over 2BC. All right. My friends, go ahead and plug in what you know, then check the board to see how you're doing.
Yay! Equals B's 3.8 squared plus 3.
Wes. And why don't you go ahead and try this whole problem before checking up here again. Okay, a couple things that you might have made mistakes on. Yes, you take the inverse cosine of both sides. That will undo this ratio, leaving you with just the angle. And then you take the inverse cosine of the right-hand side, which is that ratio, which will leave you with the angle. Okay, now, we were asked to solve the whole triangle. We only have one piece of it so far. I still have two missing angles. What strategy could I use going forward?
Sine law and then
Okay, good. There's one method I could use. I could go for the sine law.
Does tangent and stuff not work anymore?
Someone have an answer to that question?
Because it's a right triangle. Okay.
Correct, you're not in a right triangle.
I just
Okay, could use sine law and then sum of int angles. Anybody else see a different strategy I could use?
You could keep doing cosine law.
I could keep doing cosine law. I'm not going to do that. What kind of triangle was it? What kind of triangle is it? It's isosceles triangle. So what do you know about angle C and angle B? They're equal. Okay. So 180, take away this, split it in half. Yeah, does that make sense? I'm going to do it both ways. I'm going to quick use the sine law for you,
Well, if we can.
and then we'll move on from there. So sine law, now I have a completed ratio. And let's say I'm looking for angle C. So I've got the sine of angle C over side length C. I'm just going to plug in what I know right away. 3.8 equals my completed ratio, which is the sine of A, which is right here at 36.8 over 2.4. Multiply both sides by 3.8 and take the inverse sine of both sides. I'm going to end up with angle C is going to be equal to 3.8 times the sine of 36.8 over 2.4. Take the inverse sine of both sides. I'm going to try to do that all in one big step. Clear, clear, clear. Second function, sine. I got an open bracket there. That's good. I'm gonna open another one so that I can do my numerator. 3.8 sine 36 36.8. They just opened another one for me, so I have to close that one and close my numerator. Then divide by 2.4. Then close the original open one. Enter. 71.5. Okay? You're going to notice that
71.6. That's weird.
I think it's 71.6.
I got 71.5235. Anyway,
Oh, you probably typed in like answer for the 38. For
Mm.
36.8.
I did it all in one step. I didn't do any in between steps. I did the whole thing in one shot. So mine is better than yours.
Really? Well, guess
For this
what?
one?
Check it.
No, I
I got
didn't.
another domain error. Let's go.
Okay. Then
71.6.
I know I can take for angle B, I can just go 180 minus 36.8 minus 71.5. And you'll notice that you're not actually going to get an exact right answer here because we've rounded somewhere in here. So basically, a lot of times, here's what you would do. You would you'd round to whole numbers.
Rolls.
Whole numbers would help. But even that, you'll be 1 degree off if you rounded to whole numbers at this point. But anyway, go 180 minus 36.8 minus 71.5 equals, you get 71.7. Okay, and we would end up, again, you would round these probably to each at 72, and this guy would round to 37, and then they'd actually add up to 181. But it's just estimating. Okay, that's how you would use it if you went to use sine law. The other way to solve these last two would be to say that, oh, I know it's an isosceles triangle. So I know that these guys can be split in half, or sorry, that what's left after I take 37 away from 180 just gets split in half. So I know that these angles, I would go 180. You don't need to write this necessarily. I'm going to round this to 37. I'm going to take that answer and I'm going to cut it in half. And that's what angle B is equal to. Okay? So you get 180, clear, 180 minus 37, enter, divide it by 2, 71.5. And then you could say angle C is also 71.5. And we were asked to round to the nearest angle, or nearest degree, I think, or maybe it didn't even, yeah, to the nearest degree. So you have all those. You've got the angle A, 37 degrees, angle B and C are 72 degrees, rounded to the nearest degree. And again, if we solved in a different order, like if we started by solving for angle B, we might have ended up with a different, like it might be off by a degree or half a degree, or it might round down instead of rounding up. Those little discrepancies are gonna happen because we're rounding our answers and then using those answers again and then giving answers that are rounded, okay? So don't be too thrown off by those kinds of things. Okay, you have a little bit of key concepts on the back of your last page of your booklet.
Last page.
Last page for the year.
I was expecting more hype there, but okay.
All
Kinda
right.
got mad at you.
What does it say? You can rearrange the cosine law to find an. You can rearrange the cosine law to find what?
Angle.
To find an angle. If you know the three sides of an acute triangle ABC. For example, once you have found one angle, you can apply the sine law in order to find the other angle. Once you have two angles, you can apply the sum of interior angles. Okay, that's not on there. But oh yeah, no, it is on there. To find the third angle, apply the property of triangles that states the sum of interior angles is 180 degrees, or angle A plus angle B plus, that's awkward, plus angle C equals 180 degrees. And the last thing, when solving trigonometric problems, solving trigonometry problems, there is often more than one valid strategy. Okay, quick review of the tools that are in your toolbox. Let's go right angle triangles. Right angle triangles, what can you do? SOHCAHTOA.
Love it.
What else?
We've got sum of interior angles.
Sum of interior angles.
What
else?
We've got.
There's one more.
A squared plus b squared equals c squared.
Okay, Pythagorean theorem. What if it's not a right triangle? It's just an acute triangle.
We have sum of interior angles.
Okay, you've got sum of interior angles again. Can I use SOHCAHTOA?
No.
No. Can I use Pythagorean theorem?
No.
No. What other two laws do I have now?
You have the cosine and sine law.
Sine law, cosine law. Okay, start looking at the easiest laws first. If you can't use those, then look at sine law. If you can't use that, then look at cosine law.
You
Okay?
can't use that. It's probably not a triangle.
And your practice problems from 8.3 come from your textbook on page 373, number 2, 3BC, 4, 5, and 10.
Let's go.
Giddy up.
Last lesson.